Hello, friends. Have you ever started a project, finished it, well, not finished it, but built it to 60 to 80% and then bailed on it for 2 to 4 years? Well, yep. I did that with the Crowbox. It's a project I've really wanted to finish, but just life happens sometimes, things get busy, and as somebody who turned their hobby into their job, sometimes it's hard for me to do a project that I would otherwise get paid for. The Crowbox was a project I was doing for work for a while, and then things changed, and I was not able to do it for work, and so it has sat languishing in my electronics closet for literal years. I've tried to dust it off a couple times, haven't gotten very motivated. So, here is my proposal to you, my dear audience. I will show my build process, which is going to be messy. It'll probably involve swearing, but I think it might actually be really educational. And it'll maybe motivate me and hold me accountable. And also, I would love this to be a conversation. If you have ideas for the project, there are some things that I'm pretty good at, and there are some things I'm not very good at. And that has held me back on this project before. So maybe we can work on it together, and that would be super fun. What is the Crowbox? I talked about this for a while, and I haven't quite yet said what it is. So the idea is that I would train crows in my neighborhood to pick up trash in exchange for food, little treats and snacks. Specifically walnuts, because it's their favorite food. Ha. There are a couple of other folks that have done this. I built the original Crowbox, which is where I'm taking the name from. It's an open source project. I love when people open source things, and it's a really incredible build. And that one uses quarters or coins to trigger a mechanism that then releases foods and treats and food for the crows. There's a gentleman in Scandinavia somewhere, I think, that trained magpies, which are also a member of the corvid family, to do something similar. Um, and I thought it would be really cool to engage with other creatures in the community to solve a problem and make friends, and to really, for me, it's also a way to think about how can we use technology in a way that engages with our environment, in a way that enhances it, and gets creative about how we design and build these ecosystems. Our cities don't have to be only for people, right? They can be for other creatures, and I think it makes the city much more fun and enjoyable. Okay, so there's my little initial proposal and my why of doing the project. So if you are intrigued, this will be video one I have no idea how many videos of how long they will be. I will try to chunk them up. It'll probably be chunked up depending on my schedule. I can't promise that I will finish. I want to finish, but all I can promise is that I will do my best, and we will probably learn some things together along the way. Okay. All right. So where is this project at? And what do we have so far? Okay. So this messy box of wires includes a bunch of things. I'll scoot. I'll scoot. I'll scoot. Okay. All right. So the main thing, which I think I just messed up a little bit, because I was moving the power cord. It looks like it turned off. But the main device is a what is it? Oh, Raspberry Pi. And here, oh, past Jen, you did so good. Oh, look at that. I labeled the Pi with the static IP. That's great. That makes me so happy. What did I just say? So basically, an IP address is like the address of a computer. Oops, that's out of frame. And most of the time, that's what your internet router is doing. Your Wi-Fi router assigns an IP address to each device that connects to it. But if you want, you can set a static IP address so that this device or a given device, when it connects to the router, it's like, excuse me, please, I have a preference for an address. give that to me if it's free. And so the router was like, all right, boo, I got you. And then it assigns the requested IP address to that device. And so I did that apparently a couple of years ago, and I labeled it. I love that so much. Okay, so that makes it easier. So that means when I turn the Raspberry Pi on, theoretically, I should be able to log onto it with its labeled IP address. Okay, so I need to figure out what is going on with that Pi. I did plug it in, but maybe in scooting forward. Oh yeah, I think the power thing got knocked a little bit. Okay, so, oh, that's out of frame again. Oh my goodness, my camera work needs some work. I will get better at this, I promise. I love teaching. I'm not so passionate about camera work. It's mostly just a side artifact of me loving teaching and learning. Okay, but anyway, so the Raspberry Pi is the brain of our project. So the idea is that there's a camera attached to the Raspberry Pi. Crows are tricky, right? And so if we are going to train them to bring trash in exchange for food to reward crows for helping to clean up the neighborhood, then we need a way to check and verify that the crows are bringing trash and not just like sticks or just standing there expectantly waiting for treats, which is how you start to train them. But eventually, we will need to take pictures of what they bring, verify that it is trash or not, and then dispense a treat accordingly. So there is a camera for that. And then the Raspberry Pi will handle all of that processing power. The other stuff in this project are pretty much different little components so that I can control. Oh my goodness. Okay. So that I can control the gumball machine that will dispense treats. Hold on. Okay, I'm trying to decide if I want to move the camera. Oh, we have a light that fell off. Okay, there's an LED, which I think is a status indicator. And then this is hilarious. I was really proud of this idea. I don't know if this will actually work, but I have a gumball machine to dispense the treats. And I had a friend that helped me modify it a little bit so that there is a servo motor that is attached to the handheld crank. So instead of a handheld crank, it is now an automated crank. Look at that. So we will see if this works. When I last gave up the project, this part was where I was stuck on. So if folks have other ideas for what I could do, it was really difficult to get walnuts to come out of this. So maybe I'll have to try with something that's less wrinkly and ridgy, like almonds maybe. And then there's another motor that is somewhere that I'm remembering. So I was like, what is this cable going to? There's another motor that would open a box to accept the trash from the crows. So imagine the crows land on your contraption and they put the trash that they have brought on a specific spot where the camera can see it. The camera takes a picture. If it is trash, it opens the container in a way that doesn't make the crow fall. That's really important. And then it dispenses a treat. The gumball machine dispenses a treat. So you need two motors. You need a motor to dispense a treat, and you need a motor to open and close the trash receptacle. I haven't decided what to do. I guess maybe that's an open question. What do you do if a crow brings something like a stick that's not trash? Do you put it in the trash receptacle and then just don't give them a treat? Or do you do nothing? So that's an open question, but we don't have to solve that now. Right now, we're just asking, what status is this project in? And the answer is it's a hot, dusty mess. But that's okay. You got to start from somewhere, and it's not starting from scratch. So that's kind of cool. Okay, so the first thing that I need to do, well, number one might be to figure out where this light was coming from. And maybe I just put that to the side for now. The first big thing is to check and see where the status of this motor is. So, I need to figure out where to plug in the servo motor. And I fortunately just noticed this. Oh my goodness, I can't really see. Okay, I just noticed this connector which fits. Did I do it right? Nope, I did it backwards. Okay, that fits. And then I believe that this connector, yes, okay, this beefy Molex connector, these little babies are called Molex connectors, that is for the power supply because the servo motors that I'm using are quite large. You need a pretty powerful servo motor to turn a crank, turns out. I'm going to move my chair so it doesn't stop messing, it doesn't stop, so that it does stop messing with the Pi power supply. Then I'll restart the Pi. I think something funky happened. So we're going to plug the Pi power supply in, and then I'm going to take this beefier power supply, which is really cool actually. You can adjust it to have different voltage outputs, and I'm going to plug that in. And so what I did with that power supply is, where is it going? Where is it going? It's a mess of cables. Okay, so I cut the end of that. It was probably like a headphone jack or something like that. So I cut the end, I stripped open the wires, and then I attached it to a Molex connector so that I could pipe in power for a large servo motor. Okay, so I have a feeling that this isn't gonna like work because that would be wild. But now that I've connected everything, theoretically, the first test that I should do is to run the existing software program that I left off of and to just see if anything happens. So let's go do that. We are going to have to move camera locations because I need to get to my computer. So I'm going to pause and you'll come with me, and then yeah, we'll see what happens when we run the software. Here we go. Okay. Here we go. So I moved all the things, and now I'm gonna use my multimeter to try to figure out where things are going wrong. But I actually think that, oh, where did that just go? I think these two wires are the same color and there's two of them, so I think that that's, oh, look at that! Ah, cute, 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 cute. So I would assume that when I successfully trigger the servo, oh, that's interesting. Oh, I was like, it turned off. That's interesting. Did I do something? No, it just came undone. It just came unconnected. Disconnected. Unconnected. My wire was unconnected. Alright. Oh, that's cool. It's a rainbow thing. Huh. Interesting. And I'm pushing the wrong button. Well, the button is doing something, but I don't think it's supposed to. Okay. Anyway, alright, so the button, when I push the button, this should be turned true. And we can verify that because we're going to look at the thing. Okay, so I have not looked at this program in a really long time. Okay, so basically what's happening, this is my training. This is the general procedure for this one. So the first part of the training program is that food is freely available. So basically, like, you just kind of constantly open the servo motor. If you sense motion, oh, interesting. That's right, I was gonna start to gather photos. Okay, so if motion was sensed, then take a photo. I guess that would just be if the bird lands, so that would be the switch. So not like a passive IR sensor or PIR sensor, which would be like the garage door light sensors, or the security lights are usually PIR sensors. So if there's motion, it will turn on lights. I'm going to start real simple and just do a switch. So if the switch gets triggered, then you take a photo, save the photo to the local drive, and then use the photos to only get food when crows land. All right, because I figured that the squirrels are going to game the system. And that's kind of okay with me. I might, if the squirrels can be trained to bring trash, that's kind of fine with me. And I might just free the squirrels a little bit. Anyway, okay, so I have to tell the Pi where to save things. This is, oh, I was going to use a PIR sensor. All right, well, that's TBD, to be determined, TBD. Servo object, pulse width modulation frequency, aka like you're just setting up the servo. This was, oh, good job. So basically, this is me figuring out like at what number, because you have to like give a number to move the servo towards,
and I believe that I have a full 360-degree servo. Most servos are 180 degrees. I'm gonna have to double check that. It kind of doesn't matter, but whatever. Okay. Servos can move back and forth. The benefit of a servo motor is that you can tell it to go to a position and it will go to that position. But you have to know what number equals that position. And since I installed it on this gumball machine, I did a little bit of testing to figure out what numbers equaled a different position. Okay, so this is if I want to move it clockwise, this is counterclockwise, and this is stop. Okay, so we're tracking the basket state, which is what I'm calling the gumball machine. Okay, so then this is what's going to this is like debugging shenanigans. Okay, I don't need to deal with take photo because that's not happening. So align servo. Oh, interesting. So I did not hear the servo do that. So I'm gonna stop the program. Oh no, my recording software stopped recording. I think as I'm editing on the Pi, I'm hitting hotkeys that are making it turn off. So I didn't realize for like 15 minutes. So on the plus side, you didn't have to see me doing all this like really tiny, let me trace these wires. On the downside, we lost a little bit of educational opportunity, but here we are. Okay, so let me give you a summary of what I have discovered so far using the multimeter and just really trying to change some things in the code to see what works and how can I get the system to behave differently, because that helps me understand how things are working. Okay, so some weird wiring shenanigans happened when I've moved this project a bunch of times, and in doing so, it moved all kinds of stuff around. So that happens. That's fine. I'm not surprised. But it also means that I kind of have to figure out what I have done, and sometimes that's harder than just starting from scratch. Which I may do if I get to a point where I'm like, I don't know why this isn't working, I will just start a new breadboard. That's fine. So where I've landed, and I think we're gonna call it good for now because I've at least assessed the situation. There are two things that are not working. The switch, the clicky switch, clicky, is supposed to be read into the Raspberry Pi, and then it triggers the servo motor to open and close the food dispenser. So the switch is not being read successfully by the Raspberry Pi. I tried a few different things. It was going into a different input pin, and then I realized that it's not properly connected to ground. So I don't really know what happened there. That is something I need to fix. The second issue is that the servo motor is also not successfully getting a signal from the Raspberry Pi. And that actually makes me think that it could be a ground issue. Okay, so the servo alignment still didn't work. So what I need to do, and my brain is a little bit fried because I've had a full day of work and of taking care of myself and my dog and then noodling on this. I think I am gonna call it good. I have assessed the situation and I have an idea as to where to start for next time, which would really be figuring out how to properly read the switch in. And just as a quick, let's go and take a look at the code on the Pi. So I have kind of the code here when I want to make big edits, but because I'm lazy, I just sometimes will edit on the Pi. Hello? Oh, the Pi might have got disconnected. Oh no! Hello, Pi, please wake up, my dear. Sometimes when you're playing with voltage, the Pi will, if you connect things, it gets all upset. Oh, okay. It's just taking a while. Okay. Oh, it's more real slow. Come on, honey bear. Come on, I believe in you. Okay, so things that are working. I am getting power to the breadboard from the Raspberry Pi. So 3 volts are going into the breadboard. I have ground that isn't going anywhere. So there's something funky going on with that. I think I figured out where I'm supposed to connect ground. So ground is kind of weird. When you have multiple power supplies, you actually have to connect all of the grounds together, so that everything kind of knows what's going on. And so that was missing. So I fixed that. But that still's not fixed the servo alignment issue. So there's something else going on. So what I was trying, there's 2 wires on the Raspberry Pi that are going to input pins. So these are pins that would read sensors. This yellow one was kind of free floating, but interestingly, whatever I was doing, I must have been poking around with the PIR sensor instead of the switch, because in the code I had it as pin 20, which is the yellow pin, but the orange pin, which is pin 21, is the one that's actually hot glued to the sensor. So, and somewhere in there, there's no ground. So I don't know how I managed to hot glue stuff and not get a ground into the thing, so I needed to think about that. And probably look at the code a little bit. So I tried changing this pen, and then whoopsies, dropped it again. Okay. So the other thing that I changed was I tried to, I canceled it out. Okay, so that's why the servo isn't aligning. Okay. So the other thing that I tried to do is to all right, so so if this is true, meaning I think that this means if the voltage signal is high. But I think what I want to do is actually the opposite of that. But I change one thing at a time. So I saved, I'm gonna exit. I'm gonna run the program again to see if I get the servo. Oh, the servo's not connected. That's silly. Okay. All right. Well, we're gonna try that again. Oh, nothing. Okay, that's too bad. All right. Well, it was worth a shot. La 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 la. I think theoretically the servo one is gonna be. It's probably a. Hey, come on, come on. The servo is probably a connection error. The servo will probably be a little bit easier to fix. It is getting power from the power supply, which is separate from the Raspberry Pi. So that is good, and that's why this is not connected. I need ground and I need the signal, but I do not need. Yeah, I shouldn't need anything else because that's coming from the big beefy power supply. So there's some funky thing happening with the servo signal that's causing it to not move. Rude. That happens sometimes. Okay, all right. Well, I at least have triaged the situation, and I am much more familiar with where I left off and what's working and what's not working. So, what's working? The power supplies. Yay. Okay. My printing stuff is really, really helpful, so that's great. And kind of but other than that, most of the stuff's not working. That's okay. Welcome to projects. Okay, so I'm gonna leave it there for now. I hope that this was helpful. I really, really highly recommend anytime that you are working with electronics projects and trying to figure out what's going on, trace the electric paths with a multimeter. You can use it to check the voltage across different components to see if they are actually getting the voltage that you think they're getting. But like I said, this is a dusty project. Okay, literally dusty. Um, so yeah, I might noodle and poke around at some things in the code later this week, and I will update the video description if I figure anything out, and then I will see you next time, and hopefully we will get the switch to work. And when the switch is working, then it will read false when it's not pressed and true when it's pressed, and then it'll print giving food and food given even if we haven't fixed the servo yet. So there we go. Okay, all right. Thank you so much for hanging out. It was really fun to be able to talk this out, and I hope that you learned something. Please let me know if you have any questions or ideas, or if you want to learn more about this project. Thank you so much for hanging out, my dear friends. I'll see you later. Bye.